When it comes to orchestration in LangChain, a data structure called Runnable is at the heart of everything. A Runnable is a custom LangChain data type, a custom LangChain class that, when implemented, would give you characteristics that would help you run actions and also compose components. Those are the two main benefits that you get from being a runnable in LangChain, like a chat model, a prompt template, retriever, a tool, or runnables. So let us look at what a runnable is. Let's look at what a runnable is, what the interface looks like, and how it can be composed. So first, like I said, runnables are the main building blocks of LangChain. These are runnables at a glance. Runnables are the main building blocks of LangChain. They are the core of LangChain's orchestration. Because everything in LangChain is about building workflows, building LLM-powered workflows. And when you move into LangGraph, you get to build highly complex agents. Everything still about composing components together to achieve a certain task. So runnables are the main building blocks of LangChain, and they power the whole composability of components. And as you also have heard from the previous video, a runnable can best be described as a unit of work. It's a unit of work. So it's basically a thing that does a particular piece of work. It performs a single task. You have prompt templates, which take variables and a structure and create a prompt from it. You have chat models. They take a prompt, they send it to the LLMs API, they generate a response. You have output parsers. They take the result from an LLM response based on the type of parser they are, whether an XML parser, a JSON parser, or a string parser. They produce the data type. They produce the result in that particular data type or in that particular output structure. So it's basically a unit of work, like a tool itself is a unit of work. And as you'll find out later in this module, anything can be a runnable. Anything that can perform a piece of work can be a runnable. So we're going to be creating custom runnables. So yeah, a runnable can best be described as a unit of work. Then also, every component in LangChain is a runnable. Every component in LangChain is a runnable. LangChain treats everything as a runnable. Runnable is the native LangChain data type. I like calling it data type. I don't know why, but is the native way LangChain sees every abstraction. Is the way LangChain sees every component. Is the way LangChain sees everything in a chain. It sees it as a runnable. So all the components that come out of the box with LangChain are all runnables by default. They're all runnables by default. And that's why I said this topic is critical to you understanding how LangChain works. So every component, models, prompt templates, vector databases, retrievers, text splitters, tools, messages, everything in LangChain is a runnable. Everything in LangChain is a runnable. And as we have also said, it enables the modularity of operations and the composability of components. So yeah, that's runnables. Next, let us look at the runnable interface itself. The runnable interface. So a runnable is actually an interface that components implement so that they can have or implement the features that a runnable is supposed to have. The interface defines standard features that a runnable is supposed to have. And a runnable exposes three main methods that have to be implemented. The runnable interface has to have three main methods. Any type of runnable in LangChain has to have three main methods or attributes or characteristics, whatever you want to call it. First, it can be invoked. I don't think I've picked my pen yet. First, a runnable can be invoked. Now, what does invocation mean? It means that you should be able to pass an input to the component, a single input to the component, and the runnable should be able to generate an output based on that input. That's what invoking the runnable means. You have to be able to pass a single input into the runnable, whatever it is, a prompt template, an output parser, whatever, and it should be able to produce a single output based on the input. That's the first thing. The next attribute is batch. A runnable should be able to receive multiple inputs And for every input in that list, it should produce a corresponding output. So multiple inputs, multiple output. You should be able to batch inputs into a runnable and get outputs of the same amount. So let's say for a chat model, you should be able to send in 5 prompts. Yeah, you should be able to send in 5 different prompts. And for each of the prompts, you should get a response. So you should be able to perform batch operations. The third thing is that with a runnable, you should be able to stream the output. Yeah, you should be able to stream the output. You should be able to collect the output in chunks. Especially for long-running processes. For example, you want to do like a deep research and you want to browse like 5 web pages and collect their information. Yeah, you might need to process the results as they come and not at once. So you should be able to stream the output of a runnable and process it in chunks. So chunked outputs, that's another characteristic that your runnable needs to have. So once a component in LangChain has these 3, it's considered a runnable. So if you implement the runnable interface, you should be able to expose these 3 methods: invoke, which you're going to be using a lot, batch, and stream. Now, the last thing we're going to be looking at is how to compose runnables. How do we compose our runnables? Now, like I mentioned in the previous video, you can compose your runnables in 2 ways: in sequence and in parallel. When it comes to runnables in sequence, you have the first runnable, which is going to initialize the chain. By the way, when you compose the runnables in sequence, it's called a chain, as seen from the structure itself. So you compose runnables one after the other. In sequence, you have a chain. So the first runnable in the chain, once it receives an input, the chain is triggered. Then it takes an input, it does work, and gets an output. That output becomes the input for the next runnable in the chain. This one also does work, gets its output, and passes it, and it goes on and on and on until the final runnable in the chain, which will then produce the final output. And then the chain execution stops. So that's how runnables in sequence work. You put them in the right order, so you don't just, the order really matters. You don't put a chat model before a prompt template, except the result of the chat model are supposed to be input for the prompt template. So you put it in the right order based on what you want to achieve, and they execute as a chain, passing their outputs to the next runnable in the chain until a final output is generated. So that's how runnables can be composed in sequence, and once they're composed in sequence, it is referred to as a chain. So you'll be hearing chain a lot. Chain. Probably that's where the word LangChain came from. So that's runnables in sequence. So you can create it with the runnable sequence class or with something called the LangChain Expression Language. You can create runnables, you can compose runnables in sequence using the runnable sequence class or using the LangChain Expression Language, and these two we're going to be seeing them much later. After this video, we'll get into the code. We'll get into the code and start writing some code and creating some runnables. So you can compose runnables in sequence, and you can also compose runnables in parallel. Composing runnables in parallel is very useful for data gathering. Let's say you want to gather information, you want to gather some from a database, you want to gather some from web pages, you want to gather some from some API. You can run all those in parallel. Then gather all the information and pass it to the next runnable in your chain, or use it for whatever you want to use it in your workflow. So here, runnables execute in parallel, so one doesn't have to wait for another, as it is in running runnables in sequence. And they can be created using the runnable parallel class, which we're going to be seeing later in this module. You create them with runnable parallel class, you pass in your runnables, and they all get to execute in parallel. Or you can use the dictionary of key value pairs, where the keys are the names of the output and the values are the runnables that will produce those outputs. And the results are typically collected into a single dictionary. That's why they're really useful for data gathering. If you need a dictionary of data that you want to pass into a prompt template or you want to pass into a chat model, you can just use a runnable parallel to gather all that, to run runnables in parallel. When all the data is collected, it then goes into the next component that needs to make use of them. So very, very useful in that aspect. Now, before we go, an important fact that I need to mention about runnables is that the result of composing runnables, whether you compose them in sequence or you compose them in parallel, leads to the production of another runnable. Yeah, the result of composing runnables lead to another runnable. So if you build a chain of, let's say, 4 or 5 runnables, what you get is also a runnable. So it can be invoked, it can be batched, and it can be streamed. Yeah. If you compose runnables in parallel, same thing. If you compose runnables in a way whereby it's an hybrid setup where you have some parallelism and you have some sequence in there, it still leads to a runnable. It still leads to a runnable. So the result of composing runnables leads to a new runnable, and the same interface applies. You can invoke, you can batch, and you can also stream.